If you can't hear me, please let me know in the chat, and I will monitor the chat and do my best to speak louder or make sure we get what we need. All right. So let's look at this first option up here. It says find the general solution. Remember, when you see the general solution, you have to have a plus c in your answer. And then we have to separate the x's and y's. Notice how dy is right here. It's in the numerator. dy has to stay on this side. We can't move dy over to the other side. And some students were doing that on the quizzes. So just be careful. That means I have to move this secant squared y over to the other side. And you don't have to show this first step. But that's what I'm going to do is times by the secant squared y, so it's removed from the right side. And now it's just over on the left side. So my left side is going to be secant squared y dy. And then over on the right side, I just have 1 dx. And remember, when you have x's and y's mixed together, in this case, you don't have any x's, but you do have that dx that moves over. So you do have to separate. Now, all this is an antiderivative fact. Whose derivative gives me secant squared? So that's tangent of y. And then whose derivative gives me 1? That's just x plus c. And then the last step is, how do I get rid of tangent? We can't divide. We have to do the inverse. And then in this case, the constant is inside of those parentheses. So we just haven't done one with trig functions in a while. That's why I threw that one out there. And then the second one, I just figured this was kind of fun. So we might as well do a little more challenging one here. Notice one thing. ln of x divided by x. And then the 4. That 4 is a constant. My advice is keep the 4 on the right-hand side, which means the only thing I have to get rid of is the square root of y. So I'm going to bring that over to the other side, but how do I bring it over? We've got to do the opposite value of that. So I'm going to multiply by the reciprocal of that, and that way the square root of y reduces out on the right-hand side. Okay, so I'll rewrite this so it looks a little nicer. Now notice that 4 is a constant. I'm going to pull it out right away. And actually, this divide by x here, I'm going to write it this way. So notice that x on the bottom is just a 1 over x. And the reason why I do that is this right-hand side might scream, there's a u substitution here that we can do to make our life a little easier. All right? So now I'm able to do the antiderivative of each side. However, the left side isn't in the best looking format. And you could have written this as y to the negative 1/2 right away. By the way, this was smushed together. This part right here is our initial condition. So don't worry too much about that yet. We'll use that once we find the value of c. So let's deal with just this left side right away. We rewrote it, so now it's in the power rule side. So I'm going to add that creative form of 1 to the exponent. So if I add 1 up top, I get a positive 1/2. But if a positive 1/2 goes in the numerator, in the exponent, then I have to put a 2 out in front. So there's the antiderivative of the left side. We'll deal with that in a little bit, but now we've got to deal with the right side. And the right side, we have to do a u substitution to make this a little easier to look at. And we want to pick the natural log of x to be the u value. The reason why we want to do that is when I take the derivative of ln of x, the 1 over x appears. And that is where we can get rid of those values. So the du is going to replace the 1 over x dx. The u is going to be replacing the ln of x. So everything is now taken care of. And then remember that 4 is just a constant. And that just makes this antiderivative much, much friendlier. And again, you can put a 1 here if you want, because what are we going to do? We're going to add 1 to the exponent. That's the antiderivative. So I'll get u squared. But if I put a 2 up top, I have to put a 1/2 out in front. And then don't forget about that 4. That 4 originally was a multiplier. Well, now we know what u is. Right? U is the natural log. So I'm going to replace u with ln. And 4 times 1/2, that's going to just turn into a 2. And then I'll just go back and replace. Oh, I forgot my plus c. Hopefully you guys are screaming at me at home. You forgot the plus c. Alright, so now we're at the point. The first time c appears when it's written in terms of x and y, that's when you use the point when x is e and y is y. Right, so we're going to plug in e and 1 into x and y. And then we can do some simplifying and find the value of c pretty quickly. So the nice thing is the left side, 1, this is really like the square root of 1. That's 1. 1 times 2 is 2. Remember the natural log and e, those reduce out. So technically there's just a 1 left over. And then this is 2. Right? 1 squared times 2 is 2. If I subtract 2 over to the other side, I end up with c equaling 0. And then you go back to the spot where c was first appeared. Now, it's not the first time c appeared because we had it with u, but remember we have to replace u with ln of x. So we're going to go back to this spot, plug in what c is equal to. And you don't really have to write the 0 in there, right? Because I'm just plugging in c equals 0 here. But now our goal is to solve for y. So I'm going to divide by 2. And technically that 0 is gone, so we don't need it there. So you're left with y to the 1/2 equals the natural log of x squared. And then remember, to get rid of a 1/2 power, we raise both sides to the reciprocal power. So I'm going to raise it to the 2 over 1, or really you can just call that we're going to square both sides. When I square both sides, that gets rid of that square root, or the 1/2 power. And then a power to a power tells me my final answer, which is the particular solution, is y equals the natural log of x to the 4th power. It won't get that much more challenging. We did, if we just kind of quickly look back, what did we do first? We separated the variables. So I separated the y's on one side, x's on the other. And then I did a u substitution. And then we did antiderivatives. We found c. We used the initial condition. And then we solved for y. It doesn't get much more challenging than that. Really, the only way it gets harder is the antiderivatives might be a little bit more tricky. But the process is the same. So hopefully we're building your confidence up and you guys are feeling pretty comfortable with this stuff, because it's becoming pretty routine. All right, so I want to talk about a couple of things. The first thing is our test. So our test is going to be available starting today, I believe. It's not due until Sunday, April 4th. So if you're not confident in it right now, don't start it until you're pretty confident. And if that means, and I know we got some holidays coming up this weekend, think about the time that you have with your family and just plan accordingly. It is going to be a 50-point test. It's on Schoology. 5 points, so an extra 5 points will be just posting your worked out solutions to Schoology. So I just want you to remember that. You always show all your work, submit it to Schoology, even though 3 of the questions are file upload questions, so you do have to take pictures and submit them. But I'll tell you what, some people are still having some issues with uploading, and that's why I posted the solutions to Schoology afterwards. I go back and look at those for 3, 4, 5 people every time I grade tests, so it's really helpful for me to know that if it doesn't show up on the upload, it is also there on Schoology. So there's, when I say 10 questions, one of them is the academic integrity statement, where, so that, I mean, that doesn't count for anything. So really, there's 9 questions. 6 of them are multiple choice, and 3 are file upload problems where you got to show your work. Okay. We're going to allow 90 minutes on this, but I really think if you know what you're doing, it'll take 45 minutes max, and maybe a couple extra minutes for just uploading your picture. But you do have a 90-minute time limit, so make sure you're fully ready when you start. We're only going to cover section 7.1, 7.2, and 7.3 from our textbook, which covered the following topics. Differential equations, that's our general theme overall this unit, dy dx. Separable or non-separable. So non-separable problems are just like what we did in the warm-up here. I take that back. This one actually had to be separated as well. So really, non-separable is the ones we've learned in the past. Those are the ones that you don't have to move things over and you just answer the question. Maybe that's a U substitution or not, but the non-separable means... Can we do an example? Sure.
Non-separable?
Yeah, let me show you a quick non-separable one. If I just make it up, let's say that I give you right there. So it's already set up. There isn't any x's or y's. It's all one variable. So in this case, if I ask you to do the antiderivative, you might have to do a little u substitution for this one. And I'm going to show you, remember how that 7 is going to be a little problem when we take the antiderivative, so we actually have to move it over. So without fully setting this up, the answer here would be e to the u, but u is 7x, so I really am not going to write that. I'll just put the 7x here. But then this 1/7 would come out in front. And you technically don't have to do a U substitution for this problem, but you could if you wanted to. And then doing the second part here, if I write x squared, I'll put a squared here, but remember that squared is going to divide that by 2. So 4 divided by 2, we just put a 2 out in front. And that's a non-separable one where it just means you don't have to move the x and y over to the other side. Okay? So it's kind of like a basic one. And we have an example like that in today. Remember in section 7.1 we had to verify those solutions. So we said, here's the answer. Can you make it look like that? And you just have to take the derivative and move it over so it looks like that. You should have that in your notes. You can go back. We are asking you to find general solutions or particular solutions. So the warm-up we just did, we did both. Right? The example I did right here, general solution, because we had the plus c in it. Okay. And then growth and decay problems, I have one of those in our in the notes today, so we'll go over that. In general, that was kind of that PERT formula that we talked about. And then slope fields was the last big concept, and we're going to do a little bit more review on that. The best practice, if you want to get very well prepared for this test, it's that optional chapter review worksheet that we talked about from Monday. And the answers are posted in Schoology. So even though you're not getting any credit for it, I think that review is very, very helpful. I know one problem specifically is almost identical to one on the test. So there's more incentive to do that. All right, so here's what we're going to do. This did not appear as the best that I thought. At home, you guys can probably read this pretty well. Can you guys see this in the classroom? Your eyes are better than mine. Okay. At my computer at home when I was creating this, it looked a lot better. So here's what we're going to do. I don't want you to spend time writing all this, but we want to review slope fields. So part A says, sketch the slope field for the given point. So anywhere there's these dots, you want to find the slope for those. And then it says, sketch the solution curve that passes through that point. So let's do this kind of in chunks. I want you guys to work through part A really quick. So what would you do? Just draw a rough sketch. And we're going to go one to the left, one to the right, and then we've got dots for all of those points. Okay, and there's 12. There's dots here at the x-axis as well. And remember that idea of patterns. Look for the zero slopes or the undefined slopes first and see how quickly you can fill those in. So we'll give you 3 minutes on this and see if that's enough. Remember the patterns that we talked about, and hopefully you're feeling more and more confident with these. I always look for what will make this have a zero slope. Well, anytime I have a zero slope, that means I've got a number divided by, or 0 divided by a number. So I want to make this part equal to 0. Well, what's going to make this equal to 0? Anytime x is equal to -1, we will have 0 slopes. So that's this spot right here, which means all of these points are going to have a 0 slope because that's when x is -1. Now, I should actually say I made one tiny mistake right here. There's actually something more going on right here that I didn't really think of right away, so I got to be careful on that point. Then I'm going to look at when do I have undefined slopes? So I have a number divided by 0. Well, that's when the bottom is equal to 0. What makes the bottom equal to 0? Whenever y is 0, I will have undefined slopes, which means I'm going to leave these blank, which I recommend leaving them blank, but if you drew a vertical line in there, that also represents an undefined slope. They accept either way on the AP test, okay? Just so you know. But that's why this point that I had originally right here, it's not 0, because if y is 0, it's undefined, so we can't put a zero slope there. Which means now I really only have to figure out the other values. And hopefully we can kind of do this in our head, but let's think about this. Well, what happens when x is 0? That's all of the points on the y-axis. So if x is 0, I will automatically have 1 on top, and then that means that the y value controls the slope. So let's think about this. If I go over 0 and down -2, this slope right here will be 1 over -2. So that's going to be a -1/2. So think of it as going down 1 over 2 and just drawing a line that's about that slant. It's got a slope of -1/2. You don't have to be perfect on that. That's an estimate. So what about if y is -1? Well, that would be a 1 up top and then divided by -1. So that's going to have a slope of -1. So I'm going to just kind of connect a point to a point. I'm going to draw that here. And you should be able to tell that this slope that I just drew is a little bit more steep than the one below it. And that's really all they're looking for. So what about if y is +1? Then that'll be a 1 over 1. So that's going to be a slope of +1. So I'm going to kind of connect a line from one dot to the next. There's a slope of +1. And then here I get 1 over 2, so that would be about a slope of up 1 over 2. So I'm going to estimate a line that isn't as steep as the one I just drew, which is less steep. And that's how we can do this without creating a big, long table. So now, let's look at what if x, let's do this maybe in blue again. Right here, when x is 1, that's automatically going to give me a 2 up top. And then the y value, we're just going to go through and say, okay, well, at this point right here, I'll have a 2 on top and a -2 on bottom. So that slope is a -1 slope. So I'm going to kind of estimate that as a -1. At this point right here, we're going to have 2 up top and a -1 on bottom. So I've got to go up 2 over 1. And this should be a -2 slope, more steep than the one that I just drew. And then same thing with what happens when y is +1. Well, that's going to be a +2 over 1. I'm going to go up 2 over 1 and kind of estimate that slope. And then at this point, we've got a 2 over 2, which is a +1 slope. Okay. Now, it looks kind of messy with all those extra pieces written in there. You're not going to get any extra points for writing those slopes. So I kind of like to have those disappear. And then the question said, sketch a solution curve that passes through the point 0, -1. So we're going to go over 0, down 1. That's my point, or my solution. That's where the curve is going to go through. And now we're going to estimate. What that means is we're going to follow the slopes. But notice, these slopes don't change. They're constantly changing. So that means this slope is going to get closer and closer to an undefined slope, so it's going to start curving up. And when I cross the 0 line, it should be an undefined slope there. And then it's going to start curving a little bit more, and it's going to have a parallel slope to all the values when it crosses the y-axis, and then it's going to kind of go. Notice how it, forgot my, this is not going to be the perfect curve, but it's actually going to look like a sideways parabola. And I don't really need to go through that point, but maybe I do. All right, part B. This is the analyzing part. So now they're asking us, while the slope field in part A is drawn at the 12 points, Remember that this is true for any point. If I have a random point right here, that has a slope. Any point on this graph, any spot you pick, has a slope. So in general, we want to kind of generalize this and ask ourselves, describe all the points on this plane for which dy dx is -1. Right, so I want you to think about that. I'll give you a minute or two to think about it. When will dy dx always produce a -1? Super easy. Now, could you identify the points that we've already found and said, oh, well, at this point there's a -1 slope, and at this point, yeah, but that doesn't meet every point. So we haven't done this specific problem yet, which is why we're covering it right now. But if dy dx is equal to -1, let's take the equation that dy dx is equal to and set that equal to -1 and watch algebraically what happens. What if I move the y over to the other side? So if I times by y, I get -y equals x plus 1. And then I want to solve for y, so I'm going to divide everything by a -1. That's an equation, right? And what that actually is that's the line. If I start at -1 and then I have a -1 slope, every point except for right here at 0, because we know that when y is 0, it's undefined. But this purple line that I drew represents every single slope that will be -1. Okay? Now, what if I asked you, instead of saying find when it's equal to -1, what if I said find when dy dx is equal to 0? So if I ask you to do that, watch what happens. We set the dy dx equal to 0. I still times by y, but 0 times y is still 0. And then I would solve. And we already knew that because we interpreted it just by looking at the patterns. But if you set dy dx equal to 0 and you times by y, you get x plus 1 equals 0, or if you solve, anytime x is equal to -1, it will produce a 0 slope, except, and that's what they told us for right here, except for when y equals 0. Right? So this part is undefined right there. And this will be the same thing here. When y is equal to 0, we will get an undefined slope. But everywhere else, we'll get a slope of 0. That make sense? Kind of? Okay. And then the last one, find the particular solution to the given differential equation with the initial condition 0, -2. So now it goes back to just the warm-up that we did. So I'll let you guys do part C here. And I'll tell you, the reason why I chose this problem is there's something that will occur at the end when you're finding your final answer that was very similar to our quiz. And some of you, if you looked at the results when I graded your quiz, I said you got a 3.5 out of 4 because you missed the sign value in your answer. So I'll show you this has the exact same thing that occurs. All right, so what do we have to do? We have to separate the x and y. Notice this is a divide by y. So I'm going to times by y on both sides to get the y over to the other side. And then I get an x plus 1 dx. So the x's and the y's on the same side. And then we're going to take the antiderivative. So I'm going to add 1 up here, so I'll get y squared. Remember, you're going to put the 1/2 out in front. Here we'll get an x squared with a 1 half out in front, and then the 1 turns into an x plus c. So nothing crazy there. Now we're going to use the initial condition. So I'm going to plug in -2 for y. I'll plug in 0 for my x's. And the nice thing is you can kind of quickly see -2 squared is 4. Half of 4 is 2. So I found c pretty quick. And we're going to go right back to where c first appeared. And we'll plug in our c value. So nothing crazy yet, right? We do have to solve for y. So what I'm going to do then is I want to get rid of this 1 half by timesing all sides by 2. Then I'll distribute the 2 into parentheses. Now here's the part where you have to really be careful, right? We have to take the square root. But when I take the square root of both sides, I get a plus and I get a minus. But one of those is wrong. And this is the piece that some students, they did everything perfect on the quiz. Make that look like a 4. Except for they didn't check your initial condition, right? This tells me when x is 0, y has to be a -2. It can't be a +2. It has to be a -2. So we're going to check using the initial condition. If I plug a 0 in here and here, the only way my answer is going to be a -2 is if I say my answer is the value that has the negative. So that positive is going to be erased. And that's something that it doesn't come up often, but it comes up often enough that we really want to make sure you're aware. That's why the value is negative, because the initial condition had an output that was negative. Okay, so when you go back and look at your quiz, that might be the only thing that you missed. Okay. We are going to do, because we haven't done this in a while either, we're going to do a growth problem and decay. So I don't want you to write this. I mean, maybe you don't even have to write it down. It's up to you. That's a little small, so I'll make this part bigger. It's basically saying a colony of bacteria is dying off at a rate modeled by the differential equation dB dt. Now remember, capital B is going to stand for bacteria, T stands for time, where T represents the number of hours since the experiment begins. If there are 9,120 bacteria present at time 0, notice this right here in the words is my description. That is my initial condition. Right? They tell that to you, but they don't give you the ordered pair. It's just written out in terms of words. And then the question is, how many bacteria are present after 1 day? Well, to do all this, we need to use the slope or the rate and undo it as if it was a differential equation, which it is. So really, another way to ask this question is find the particular solution. So that tells me when t is 0, we know the initial condition. We also know, now keep in mind, this is dB, right? dB, and then here's B. So this B has to move over. Don't bring the negative point 19. That's a constant. Leave it there. Otherwise, it can get messy. You could bring it over, but we don't need to. So I want to get rid of the b by multiplying by the reciprocal. And then when I do that, I'll get dB, so 1 over b dB, and I get negative 0.19 dt. So that's the separation of variables, which we've done a lot. So hopefully you're getting really comfortable with this. The only difference is it's not x and y, it's b and t. Now, the negative 0.19 is a constant, so I'm just going to leave that on the outside. And then we're going to do the antiderivative. Whose derivative gives me 1 over b? That's the natural log of the absolute value of b. And then the antiderivative of dt is just t plus c. Notice, c appeared. As soon as c appears, we're going to use the initial condition. I'm going to plug in my t is 0. I'm going to plug in 0 for t. B is 9,120. Which tells me exactly what c is. The natural log of 9,120. Now I will note, if you've done a lot of these problems, you could have skipped everything we just did, because there's a pattern here. This is the PERT formula in disguise. But not a lot of students see that right away. So I don't think there's any harm in going through doing the work that we're doing here. But now let's go ahead and put that plus c right back in. And they don't tell me. They say how many bacteria are still present after 1 day. Well, I can't do that until I solve this. Actually, you could right now. By the way, 1 day is when t is equal to 24 hours. Because t represents the number of hours, so we have to put 24. You could put 24 right here and then just solve. Or, if we went through the algebraic steps, and I wanted to just solve for b, we get e to the negative 0.19 t. And then, remember how this addition right here is really a multiplier? So this e and this natural log will reduce out, and then it's a multiplier, and that 9,120 comes out in front. That was the undoing of that exponent property we talked about before. Now technically we have that same situation we did in the last example. This is the absolute value of b, which means this answer is going to be positive or negative. Well, let's use our initial condition. If I plug in 0 here, this answer will always be positive because it'll be e to the 0. So we only have to take the positive sign value. There's my equation. You don't have to write this, but doesn't that look like the PERT formula that we learned way back in Algebra 1? So you technically could go from here to here if you understand the pattern that's involved. If not, do the work that we just did. But we're not done, right? We have to now solve this problem when t is 24. So then you just grab your calculator. will give me the amount of bacteria left over after 24 hours. They just call it bacteria. So I'm hoping that now with this review, we've really done the same process all day, all unit, right? Separate the variables, do the antiderivative, and then there you go. I want to make one little note. If I gave you this equation right here, without any context, how do you know that this is a decay function? How do you know the quantity is decreasing over time? The rate is negative, right? So that's something, they could ask you that. How do we know that this is a decay problem? Because it's negative. Yes, Jonathan, I'm recording this. All right, so I had this put up here. We're not going to do this one. We didn't have time, which is completely fine. Here's what we got for the rest of our time here. I want you to make sure everybody's aware. The Unit 7 review worksheet is in Schoology. It was what we did on Monday. So I highly, highly recommend you all looking at that. I'm going to show you where it is mostly so I remember. If I put it in the week 3, oh, you can actually get it right here in our agenda for this week, or in the Monday folder, it's right there as well. But I can't encourage that enough. Do the review worksheet. I will be available for help from 12:55 to 1:30 today, if you guys need help. Also tomorrow, if you're not in school, tomorrow I will be available from 12:55 to 1:30. If you have any questions, you can join. And then our test will be available starting this afternoon. You could take it as early as today or as late as April 4th at 11:59. And then just remember, all missing homework from this unit, including quiz corrections, must be done by April 4th. So that's all I have. Those of you on Zoom, adios. Come back in the afternoon if you need any help.